and good morning to everybody. It's a pleasure for me to be here and see a lot of already known faces. I like the work you're doing over here. It's an interesting and rewarding work to bewaring the Erde. So congratulations for your effort to bring conservation agriculture forward. Dr. Strauss gave me at the beginning the title for my conference, My Experience with Conservation Agriculture No-Till, but later he said I should give emphasis on why conservation agriculture. So I'm mixing a little bit of both. And a brief overview of the content of my presentation. I will start with an introduction, a little bit of history, and show you the worldwide adoption of conservation agriculture no-till. I will also define what I understand under conservation agriculture no-till, because I like to define what these terms mean, because sometimes there is a misunderstanding of what we are really talking about. Also, we are going to treat in detail why we use conservation agriculture, why we should use conservation agriculture, and lessons learned in conservation agriculture no-till in this country and all over the world. And I will end with some final remarks. It was a pleasure to greet a group from South Africa in the year 2004. We see Andre Roux also in the first picture. I'm pleased to see you here, Andre. And in 2012 we had this wonderful group that we have a wonderful excursion through Paraguay and also Brazil. So my experience with conservation agriculture no-tillage goes back to 1971, when I compared conventional tillage and no-tillage. And interestingly for me, always no-tillage, this plot was a little bit greener, a little bit better than the other, so that caught my attention, and I thought, well, let's follow it up a little bit. I was fortunate, which is seldom for researchers, that a farmer was interested in what I was doing, and in 1972 Herbert Barth started no-tilling, and a stubborn German, he went along all the difficulties he had in a time where only 2 herbicides were available for no-tillage, 2,4-D and paraquat, nothing else. So he really did a good job in starting no-tillage going in South America. What is the extent of no-till adoption in Brazil? They now have 25.5 million hectares. But as I said, Herbert Barth started in 1972. And that year, the United States had already 2 million hectares of no-till being practiced by farmers. So the knowledge was in the United States and also in the United Kingdom, where they had developed paraquat and diquat from the system. But notice that it took off very slowly, and it took almost 20 years to get to 1 million hectares. From there on, about the year 1990, it grew exponentially, and now we have these 25 million hectares of no-till in Brazil. This slide shows you the global overview of no-till adoption, and you see that the world total is 125 million hectares. And these yellow circles indicate you the percentage of no-till adoption in relation to this number, 125 million hectares. So in this region there is the greatest adoption of no-tillage, followed by North America. The columns show you the number of hectares, in million hectares of no-till adoption. Also in Australia we see 70 million hectares adoption, also in New Zealand. Then we follow with Asia, where we have only a smaller adoption, 7% of the total, and Europe has a little bit more than 1%, and the lowest adoption worldwide is in Africa. And from this 1 million hectare that is practiced in Africa, 1/3 is done here in South Africa. So this is to give you an overview of the adoption worldwide. Then I put also this slide which shows the adoption of no-tillage in Australia in percentage. In the year 2004, they had already 82% adoption. At the moment in Western Australia, they have more than 90% adoption. And I would say that Australia has the most similar situation of yours, so I really would encourage exchange with Australians because they have a similar environment that you have. The other places where you have that environment is Mediterranean area, Spain, Portugal, and etc., where there is a lot of no-till adoption, and also in Chile, where they have a Mediterranean climate in the south. So they have, in the country, they have 17 million hectares of no-till adoption. So the question is, why conservation agriculture no-tillage? And this slide shows you one reason. In Argentina, from 1880 to 1980, in 100 years, organic matter went down from 6 to 2.5%. So this is something that happens in conventional tillage. We are degrading the soil, organic matter goes always down, and then the soil produces always less. The fortunate thing is that with no-tillage we can reverse the situation, because as you see in this slide, there's no increase after 10 years of no-tillage adoption in the organic carbon content in conventional tillage, the red line, while there is a huge increase in the top soil layer in the case of no-tillage. So we can revert that situation. Another reason why conservation agriculture, because we want to avoid what you see here, and these pictures are from South Africa. So that's what we want to avoid. We don't want to have a degradation like the one you will see in the picture. Then another reason why we use conservation agriculture is because it increases our yields. And this is a farm of Frank Dijkstra in Brazil. He is Dutch descent, or he was even born in Holland and immigrated. He has an 800-hectare farm, and this is the average of 800 hectares. When he started in 1976 or 77, no tillage, he produced 4,000 kilos of corn per hectare. After 20 years of no tillage, he doubled his corn production to about 8 tons. Then he started with about 2,000 kilos of soybeans per hectare. After 20 years no tillage, he finished up with about 3,600 kilos per hectare. And the interesting thing is that he could save on corn 30% fertilizer, and he could save 50% on soybeans. So with less input, you produce more. I don't think that everybody is going to achieve this. It depends on how degraded the soil was, how the conditions are, and I would remind you that this is true no-tillage with a lot of cover crops in between, rotation, and a disc seeding system. Then another interesting thing that happened in South America is that Brazil and Argentina, the same picture happened also in Argentina. They doubled the production in the same time where you had this big increase of no-till adoption. In the same period, the area under production increased very little, as you see in the green line, but the grain production of the country doubled from 57.8 to 125 million tons in the period of 91 to 2004, only 15 years. This slide shows you the percent no-till adoption in relation to total cultivated area. In the United States, which is a country that has the biggest area in no-tillage, approximately 26 million hectares, they have only 25% of all agriculture is no-tillage. Well, it is more than 70% in Argentina and Brazil, and 75% in Paraguay. So adoption is quite strong over there. The main barriers that have to be overcome to really adopt this technology, in the first case, it's knowledge. Knowledge is the main factor why no-tillage is not being adopted more widely, because this knowledge has not been spread as much as one would desire. Mindset and tradition is also a big reason, because it looks like European and European descent people have the gene of tillage and mechanization in their heads. So it's sometimes difficult to switch to new technology. Of course, the availability of adequate seeding machine, despite the fact that worldwide there are more than 100 manufacturers of no-till equipment, it's still in some countries a limitation to find the proper seeder for your conditions. And you have to have the availability of suitable herbicides and cover cropping systems to control weeds and put the right rotations in place. But it is also necessary that the government puts the right policy in place, because if the policy is not conducive to adoption of this technology, then adoption will remain low. So the question, what is conservation agriculture? FAO defined four basic principles of conservation agriculture, and these are the absence of tillage except for a narrow slot and carried out consistently from year to year. That means application of an no-tillage technology, because it's the only way of getting that first principle. Permanent soil cover, and permanent means throughout the whole year you need to have a cover on the soil. And diversification through crop rotation and green manure cover crops. Diversification is an important principle of conservation agriculture, and if it's not followed, then the system does not work very well. Corrupting the principles means not gaining all the benefits of the system. So we have to keep these three principles always in mind, and if you go to the homepage of FAO, you will find these principles written in their homepage. Then the question, what is no-tillage? No-tillage is also defined by different people, sometimes differently, but I would like to convey you the most widely used definition of no-tillage nowadays. No-tillage is a conservation farming system in which the seeds are deposited into untilled soil that has retained the crop residue from the previous crop by opening a narrow slot, trench or hole, only of sufficient width and depth to obtain proper seed coverage. No other soil tillage is done. And permanent or continuous no-tillage is meant, rather than not tilling in one season and tilling in the other, or occasionally not tilling the soil. So this is what we define under no-tillage. And no-tillage is a holistic cropping system that not only includes no-tillage and permanent soil cover, it includes rotation, cover crops, and diversity. We would like to integrate animal production with crop production, if possible, also trees. What for? For obtaining sustainable agricultural system, but this is not the end. The end is the farmer family, and especially the small ones in this picture, which we want to give a soil that is at least as good or better than the one we received from our parents. So no-tillage starts with the harvest of the previous crop, but uneven distribution of residues will result in poor performance of herbicides and poor performance of seeding machines, because you will have thick residue on one part and thin residue on the other. So this is the first step to go to a no-tillage system. And you wonder, these 125 million hectares, it's a lot of hectares under no-till. And I've followed up a little bit, and no-till cover cropping systems are working under all kinds of environments. From the equator, for instance, Kenya, Uganda, to 50 degrees south in Argentina, or to the polar circle in Finland, you find people, farmers, using no-tillage. From sea level to 3,000 meters altitude, in example, Bolivia and Colombia. In soil from 90% sand, for instance, Australia, Brazil, probably also South Africa, to 85% clay, for instance, Brazil, oxysols and alphasols. And from 250 millimeters of rain, for instance, in Western Australia, sometimes only with 180 millimeters in the growing season, to 2,000 millimeters or 3,000 millimeters in Brazil and Chile. So if somebody says, well, like this farmer, no-tillage works all over the world, but I have a special soil, no-tillage will not work on my farm. This is the most recurrent answer I have found all over the world of farmers that do not want to adopt the technology. They have a different soil. And all crops can be planted in no-tillage. This is onions in Colombia. They plant no-tillage tomatoes in the United States. You can, all the vegetable crops. I've not seen any crop that you could say this crop cannot be done in no-tillage, except, of course, potatoes that you can do it in no-tillage, but when you dig them out, you have to till the soil, or perhaps other root crops. This is a reminder. Agriculture is always site-specific, but the principles of farming are the same all over the world. That means if we are now using examples from Brazil or Paraguay or other countries, we have to respect the basic principles which are the same all over the world. So, a list of reasons why we should use conservation agriculture. First, stop soil degradation by wind and water, erosion, organic matter depletion. We want to imitate nature, because this is what no-tillage does. It tries to imitate nature. We try to keep the soil covered. Another reason is to enhance water infiltration into the soil. The more cover we have, the better the water infiltration. We would like to avoid soil crusting that you achieve with a thick cover of the soil. And farmers want to increase organic matter content of the soil because we produce more. And we would like to enhance physical, chemical and biological soil properties, which we can do with the no-tillage technology. Of course, in warmer climates, we want to reduce the temperature of the soil and improve soil moisture retention and water use efficiency. This is especially important here in your area with low rainfall in many regions. We would like to reduce the energy inputs to produce crops and save fuel. We would like to increase yields through time. And another reason is, the main reason is because we want to increase economic returns, and this is the bottom line. This is what the farmers are after. They want to increase the economy. This is no-tillage on large farms in Brazil. 12 units, seeding with 64 meters width, following 31 combine harvesters. And I would like to remind you that in Brazil and all South America, they only use discs. The tines are virtually not used. So the question is, does no-tillage only work on bigger farms? No. It works with a planting stick. It works with a small hand-jabbed planter. It works with machines that have been developed in Brazil with animal traction, with one row, or two row where the operator is sitting, or a sophisticated machine that is pulled by these pair of oxen. So this is high-tech being used with oxen technology. And as I said, virtually all no-tillage in South America uses this. In this picture we are harvesting on one side and no-tilling on the other. In contrast, in South Africa, most people use time still. But disc seeders cope well with stone. This is Dr. Johann Strauss's Kuhn no-till seeder, which seeded this crop under this stony condition. So if somebody comes along and tells me, yeah, but in South Africa we have too many stones, we cannot seed in this condition because the soil is too stony. And in this field we were just this last week, you couldn't see the soil because it was all stone. And still the disc seeder worked perfectly well. So what are the lessons that we have learned in the meantime? This is Carlos Crovetto, who wrote a book, Stubble Over the Soil. He is Chilean and is in a similar environment as you are over here. The percentage of soil covered with plant residues is the overriding factor that influences water infiltration into the soil and reduces runoff and erosion. Some people think that if you plow the soil, if you loosen it, then you get more big pores, you get more infiltration. Wrong. You probably have seen it yourself. Where do you get erosion? Where you have tilled the soil, where the soil is bare. If you have the soil covered, then you virtually have no erosion. And this is research we have done in Brazil, where you see that we have here the increase in the soil cover and the runoff in this plot. We applied a 60 millimeter rain in 1 hour, which is a common rain for us in that region. And it was a rainfall simulator. When we have no cover and we use conventional tillage, chisel plowing, and no tillage, you have about 75 to 80% runoff. Runoff means erosion, but also it means that you are losing the water into the creek instead of harvesting it into the soil. So what happens if we increase the soil cover? When we arrive at 100%, all three systems have no runoff. So either you no-till, you chisel plow, or you use a normal plow. The moment you have naked, bare soil, you will have a huge amount of runoff, and when you cover the soil, the water will infiltrate into the soil. And this is an interesting experiment they do in the No-Till Conference in Salina, Kansas every year. They have a beautiful conference in this place. And then in the conference rooms, because it's snow and cold outside, they do this test with a rainfall simulator. In about 20 minutes, they apply a lot of rain on 100% soil cover, 30% soil cover is zero soil cover. Then you see there is less water when you have 100% soil cover, and the water is clear. When you have only 30% soil cover, you have more water in the glass, and it's brown with sediment. The moment you have no soil cover, you have a full glass and really all the sediments in the glass. It's a thing. In 20 minutes, they do this demonstration, and it's really wonderful. You see it also in this picture, which was gently given to me in Switzerland, where you see Terezza, zero tillage on the left, and plow tillage on the right. Here, you can enter the field with your Sunday shoes, and they will not get dirty. While here, you need to have on the right side of the picture, you need to have boots in order to walk through the same field. This is, as you see from the landscape, they are adjacent. The only difference is that one is no-tillage, the other is plow-tillage. And if you have some point of water over here, it's because they have taken some soil samples and disturbed the soil a little bit where the infiltration is less. So soil cover is the most important thing in no-tillage. Almost all advantages of the no-tillage system come from the permanent cover of the soil, and only few ones from not tilling the soil. Taking crop residues away from the fields will compromise agricultural sustainability. So please don't do this. Leave the residues on your farm. Don't bale the straw. Keep it on your soil. Don't burn the straw because it compromises your sustainability. This is burning in conventional tillage systems. In South America, virtually burning disappeared with the adoption of no-tillage. Well, 30 years ago, 40, everybody was burning crop residues. Now it's difficult to find a farmer that does this practice. But I would like to convey you this message. No-tillage without plant residues on the soil surface will result in poor crop and root development and yields below those in conventional tillage. I don't know what's happening. Just a moment. Okay. Good. Research conducted by Wall from CIMMYC, the Center of International Maize and Wheat Breeding in a low rainfall area in Bolivia, shows that in all seasons, the highest yields were obtained from plots with no tillage and crop residue retention, and the lowest yields from plots with no tillage and no residue. And look how interesting this graph is. So the green one, no tillage with residue retention, different types of tillage practices reduced and so on, and finally no tillage without residue. The highest yield, no tillage with 100% residue retention. The lowest yield, no tillage with no residue. This gives you an idea of the importance of residues in the no-tillage system. Then he did this experiment in many regions and several years, and you see that here in this slide, in 95, 96, and so on, he compared no cover with 2 tons of residues per hectare and 4 tons of residues per hectare. In dry years, which is this first part of the graph, you always see higher, much higher yields, more than twice as much as conventional tillage without, no tillage without residues, and no tillage with residues, much higher yield. But also in wet years, the yields of no tillage are higher when you have 4 tons of residue as compared to 2 for no cover. And when you have catastrophic years with almost no rain, you at least get a little bit when you have soil cover, and you get nothing when you have no soil cover in the no-tillage system. Another researcher from CIMMYT did studies in Mexico, and this slide shows you the comparison of the effect of residue retention versus residue removal for zero-till rain-fed wheat yield in the highlands of Mexico, and it shows the average yields from 1996 to 2004, 8 years of research. And look at this. Wheat, maize, zero tillage, plus residue, retention, this year, almost 6 tons. Wheat, maize, zero tillage, residue removed, this year. And farmers claim that they make a business because they sell the residue. So that's why this researcher was interested in finding out, is it profitable to sell the residues or not? And this is the comparison of the same experiment, but here we are showing the average return. Look at this. The return for the farmers that are not selling the residues, keeping it on the soil, is this, and the return of the farmers that are selling the residue is this below here. So they are going to get broke in only a few years. Then he did the same thing with maize, and he found out that maize yield with the residue retention was this, compared to this when the maize residue was taken away. And then the average return, again, despite the fact that we are selling only one crop, which is a grain, and this other guy down here is selling 2 crops, which is the grain and the straw, he has lower returns from his harvest. Conclusion of this study. The use of zero-till planting system for both maize and wheat without adequate residue retention leads to disaster. Published work by Saire and CIMMYT. Both maize and wheat crop residues, when retained in the field with zero-till planting systems, have an inherent economic value that is 4 to 6 times more than their current market price for fodder. So think it over. If you're selling your residues to a neighbor, you probably will reduce your crop yields. Well, let's analyze the yields in no-till and conventional cultivation. Observations from all regions of the world have shown that similar or higher yields can be obtained with no tillage compared to conventional tillage system. Some people contest that, and the literature is full of results where conventional or reduced tillage has produced more than no tillage. But then the question is, what did the people do wrong? So if it's not the case, if you have lower yields in no tillage than in conventional tillage, it may be because there is a lack of knowledge on how to manage crops in no tillage, and the steps for successful no-till adoption have not been followed. This is all published material. So then there's a lack of systems approach. The soil was not tilled, but all else managed the same way as in conventional tillage. And this happens often with researchers because they only want to change one factor and not the whole system, because the experiment gets very complicated. No tillage may have been performed with bare soil conditions or without sufficient cover of the soil. So we have seen this right now. Lack of experience of the machine operator, that means inadequate regulation of seeding equipment. Seeding slot stays open, mice or birds eat the seeds, and so on and so on. Inadequate no-tillage machinery leading to poor plant establishment and germination. If you use a deficient no-till seeder, you will not be able to get the right results. Poor weed and pest control, for instance, inadequate selection of herbicides or dose, not system-specific application. Sometimes people use calendar application, so that's no good. N7, nitrogen fertilization may not have been adjusted during the first few years of no-till because fertilization was not adjusted to the new system. We need, when you change from conventional to no-tillage, to put more nitrogen on the crops so they produce a good yield. And no-tillage may have been implemented on extremely degraded or eroded soil, low organic matter content, low micro and macrobiological activity, and soil aggregates destroyed by decades of tillage. Under a situation like this, we may consider a transition phase. So if we have a very degraded soil, we need to regenerate the soil first before we go into no-tillage. To initiate no-tillage on a dead soil, low in organic matter will result in lower yields than conventional tillage. We have seen this right now. And this slide shows you a study made in Brazil where they show the evolution of a continuous no-till system. We have the initial phase from 0 to 5 years, the transition phase from 5 to 10 years, the consolidation phase from 10 to 20 years, and the maintenance phase when you are more than 20 years in no-tillage. And in the initial phase, you have to rebuild aggregates, you have to build up organic matter, and mainly you have to re-establish microbial biomass because the soil is relatively poor in this aspect. So you're improving the soil. I'm not going in all the details of this because of lack of time, but when we get to the maintenance phase, we have high accumulation of crop residues, we have high carbon content, high water holding capacity, high nutrient cycling, and we can reduce nitrogen and phosphorus fertilization because we have built up the soil fertility. It takes 20 years to get to that point. And important, any tillage performed in the phases 2 to 4 will bring us back to the initial phase. It means that farmers will never reap all the benefits of the system. So interruption of the system is not good. And everybody that has seen a soil that has been for a longer time in no-tillage knows the difference. This is in China, where the right clock is on a till field and the same soil adjacent conventional till field. The color tells you everything. The interesting thing is that we have the longest experiment of no-tillage in the United States that has been started in '62, and in this case the results are shown until 2005. In no-tillage, you have a continuous increase at the beginning. In this site, Hoytville, in Ohio, you have a low increase at the beginning, but then a sharper later on. This is a genuine no-tillage with corn, soybean rotation, while in conventional tillage, you are constantly degrading the organic matter of the soil. The same soil with high organic matter content gives high yield, and with low organic matter content gives low yields. On another side, Worcester, the results were more impressive, where you constantly increase very much the carbon content of the soil, and in conventional tillage, you constantly reduce the carbon content of the soil. And this is a typical curve that shows you a sustainable system and an unsustainable system, which is the lower curve. Any production system, be it crop production or livestock production system, where you constantly reduce organic matter on the soil, is not sustainable and will result in poor soils and poor farmers. In no-tillage, you concentrate phosphorus on the soil surface. And then the tillage guy says, we found a reason why we have to till the soil, because we want to distribute the phosphorus all over the... We don't need to do that, because the roots will get the phosphorus from the soil surface, and the roots will grow in no-tillage underneath the soil cover and on top of the soil, which will not happen in conventional tillage because the soil gets too hot or it has no biological life. This is Herbert Bartz taking a picture of maize that is growing exactly on top of the soil and underneath of the soil cover. Then in South America we have a lot of acid soils that contain toxic aluminum. So what we do, the old school says lime does not move in the soil profile. But we have seen it in the excursion, farmers have told us that yes, it moves, and this is also something that we have found out in South America. Lime is applied on the soil surface, and organic acid from cover crops or from other organic material are taking taking the lime to the deeper soil profile. So nobody in Brazil or in Paraguay will be incorporating that lime or diluting that phosphorus in the soil when it concentrates on the surface. And this year, soil crusting, you only see soil crusting on bare soil. If the soil is covered, this problem of high crusting soils disappears. Here we have a researcher from USDA taking a picture in no tillage where soil crusting appears to have happened. But where is it? The only place where there is no residue. Where there is residue, there is no soil crusting. Some research results show you water-stable aggregates in an oxysol in Brazil after 4 years of different tillage management. And you see the huge difference in no tillage, high amount of water-stable aggregates in the upper soil layer, but also in 20 to 30 centimeters soil depth. You see a higher water-stable amount of water-stable aggregates. Soil compaction. We use cover crops, and when you have a diversity of root systems from the crop you have available, this is lupins and this is oilseed radish, they have a strong root system that will help you tilling the soil, and then also canola has a beautiful dense root system. And why not change iron tillage by biological tillage through earthworms and animals that are in the soil? This slide shows you population of earthworm is affected now by no tillage, and you see a dramatic increase in the earthworm in no-tillage system compared to conventional. Arthropods are also increased a lot. And important in a no-tillage system is crop rotation. Of course, we have a better situation in Brazil and Paraguay, where it rains the whole year. We can plant 2 crops a year. We can plant several crops in a rotation. And this is a 2-year rotation with 3 cash crops and 2 cream and cover crops. But a 3-year rotation is always better than a 2-year rotation. Then, if we want to do something with cover crops, we need to do a screening. And this, of course, is a typical work of research. We use, in Brazil, we selected more than 100 species of cover crops. We tested them on small plots. And from these 100 crops, we selected about a dozen that work well and are now used by practical farmers. And of course, if research is not available in your region, you will have to do it yourself, because if nobody is there to do the test and show you which are the cover crops that can be used, then somebody will have to find out, and probably it's yourself. What do we do when we have selected some cover crops? Here, for instance, we see the cover crops crosswise to this picture. The cover crops were seeded this direction. Then we flatten the cover crops with a knife roller and seed in crosswise, crossing all the cover crop plots. And what happens is this. This is the yield of soybeans after green manure cover crops, and it shows you the residual effect of winter cover crops and wheat and fallow on the yield of soybeans. Interestingly, the highest yield was obtained after black oats, much higher than after all the other treatments, and also much higher than after winter fallow, which was in those days a common practice by farmers. Not only that the yield was higher, but the economic return was higher planting a cover crop and then a cash crop as compared to the traditional system, which is wheat, soybeans. Look at this. After wheat, soybean yield was quite low. So you're producing soybeans by planting cover crop. In the case of maize, we have the same experiment was conducted with maize. And then we have the following situation. As expected, the highest yield of maize after white lupin and hairy vetch, but laphyros peas did not respond very well, but it is also a legume and did not give us a good result. On the other side, oilseed radish has given us the 3rd highest yield in maize. Why? Because this green manure cover crop has a deep root system that can pick up the nitrogen that has been leached, put it in the tissue, and then return it back to the crop biologically as the crop grows. Then we tested what is the influence of a crop rotation. For instance, corn, fallow corn, which is a common, in those days was a common rotation or monoculture in Brazil. Then you compare that with corn, lupins corn, and soybean lupins corn. Without nitrogen, the yield was 2.6 tons in a monoculture. But if we have 90 kilos of nitrogen, the yield goes up to 6.3 tons per hectare. But look, the same yield we obtain in the case of soybean, lupins, corn, without nitrogen. So actually this rotation is given an additional 90 kilos of nitrogen to the crop, and if we add nitrogen, we still got an extra ton of yield. Then adjacent plots that they have been sprayed immediately after harvest and seeded, the maize and seeded. You see where fallow is, it's full of weeds 30 days after seeding, hairy veg, completely free of weeds. So rotations and cover crops are very efficient in reducing weed infestation. And this is our star cover crop. We have done this experiment. We planted crosswise the cover crops. Here you see them crosswise in the picture. And we planted this strip over here to the right with herbicides, and that strip to the left without herbicide. The cover crops had different abilities in reducing weeds. You see some of them did not have any efficacy at all. But black oats without herbicides is as good as with herbicide. So we did not use any herbicide at all over there because black oats was so efficient in reducing weeds in that experiment. And here you see it from another angle. The crop is free of weeds in the case of the no-till cover crop, black oats. So black oats of Venezuela are now planted on 3.2 million hectares only in the state of Paraná and Rio Grande do Sul, Brazil, and about 300,000 hectares in Paraguay. These cover crops have increased a lot. This is a knife roller that we use to flatten cover crops and seed the next crop on top of it. That's how it looks like. And what we have learned is that high diversity cover crop combinations get the best result. In the United States, in North Dakota, they are testing about 126 different species in one field, and that's obtained the best results. Soil temperature under bare, straw, and covered soil, we have a big difference in the soil temperature, 74 degrees under bare soil, 39 degrees under covered soil. So why conservation agriculture? According to Embrapa, no-tillage has contributed to a better management of watersheds, to a reduction of erosion, to maintaining biodiversity, to 60 to 70% reduction of fuel use in agricultural activities, and to sequestering significant amounts of atmospheric carbon in the soil. Embrapa is the same as USDA in the United States, the official research institute. And it has led to a significant reduction of risk in agricultural production. According to APRESID, which is the no-till farmers organization in Argentina, the reasons why they use conservation agriculture is because they have a 66% reduction in fuel consumption, 96% less erosion and soil degradation, reduced CO2 emissions, sequestration of carbon, and enhanced water quality, higher biological activity in the soil, increased soil fertility, and enhanced production stability and yield. And incorporation of new areas to production that were formerly not suited to agriculture. And lower production costs, which means finally more economic. So I'm going to skip a couple of slides because Dr. Strauss has told me that I have only 5 minutes left. So we're going to go ahead. Unfortunately, we're going to skip the condition for a successful adoption of no-till. We have no time for that. critical steps for no-till adoption. You will find this in my homepage, which I'll show you at the end, and also Dr. Strauss has a publication that I've sent him where this article is published. So there are 10 steps for successful no-till adoption. The Americans have also done work on this. So I'll pass to the final remarks. Before adoption of no-tillage must be on a soil with all physical and chemical limitations removed. If we start on a dead soil that has not been adequately fertilized, we will not succeed. Plough pens need to be removed by cultivation, and a balanced nutrient status needs to be achieved. To initiate no-tillage on a dead soil, which is low in organic matter, as well as low in micro and macrobiological activity, will lead to lower yields than in conventional tillage system, which we have shown before. So in this case, consider a transition phase. Generation of adequate biomass, more than 6 tons per hectare year of dry matter, and vigorous root development are crucial to restructuring of soil, which takes time. Crop rotation should be as diversified as possible and always contain grasses and legumes and be enriched with green manure cover crops. Diseases, pests, and weeds are controlled in the first instance by crop rotation and only in the second step by herbicides. Good soil cover in no-tillage is needed. In this case, you can see the soil through the residue, and this is the aim of many farmers, to have that much residues, and when you look at the soil, you cannot see the soil because the residues cover everything. No tillage on bare soil will not succeed, and we have seen that in our presentation before. Don't get caught without cover. And keep the sheep out of the cropping field. We need the cover for carbon sequestration. We need the cover for water infiltration, for water harvesting. So please keep the sheep out of the cropping field. There has been a great impact of no-tillage in South America that you know by the adoption, and this is the past of the Iguazu Falls that we visited with a group of Dr. Strauss. The past was this, and now it looks like this. So the water quality is dramatically enhanced by general adoption of no-tillage technology. The widespread adoption of no-tillage shows that this way of farming cannot anymore be considered a temporary fashion. Instead, this farming system has established itself as a technology that can no longer be ignored by scientists, universities, extension workers, farmers, politicians, donors, as well as machine manufacturers and other agriculture-related industries. So it's a technology that has shown all over the world to be beneficial, not only for the landscape, but especially for the farmer himself. And with this, danke, and this is my homepage. If you want to consult, you can write it down, where you can find some of the information I passed today. Thank you.